Now we will study how to solve the numericals of three-phase circuit, star and delta. I am giving you the list of formulae to the right hand side. Formula number 1 to onwards. You go by solving the numerical according to those formulae one by one. First, ZPH is given to you. R, XL, XC and ZPH. Everyone has unit of ohms. Unit of R, XL, resistance, XL is inductive reactance, XC is capacitive reactance and Z is impedance. Unit is ohms. If L and C are given, if L and C are given, then L will be in Henry, C will be in microfarad, etc. You have to calculate XL 2 pi Fn with unit ohms, XC 1 upon 2 pi Fc again with unit ohms, and then use these two values here. That is first. ZPH. IPH is VPH upon ZPH. IPH is VPH upon ZPH. Phase current, phase voltage upon phase impedance. Now, in the numericals, whatever voltage is given to you, it is always a line voltage. Whatever voltage is given, it is always line voltage, VA. Now for star, this VPH you have to use here. And for delta, this we have studied in previous derivations. For star, VL is equal to root 3 VPH, so VPH is VL upon root 3. And for delta, VL is equal to VPH. These two values you have to use here. That is second value, IPH. Then third, IL is equal to IPH for star. And IL is equal to root 3 IPH for delta. This is IPH, put it here. Then fourth, phi, tan inverse XL minus XC upon R. These all we have studied in first year. Phi, cos phi, either cos of this angle or R by ZPH. Then sin phi, sine of this angle, or cos phi can be taken as cos of this angle or R upon ZPH, but sin phi will be sine of this angle. If this angle is negative, then sin phi will be negative. Never calculate sin phi as under root of 1 minus cos square phi, because it will be always positive. Under root of 1 minus cos square phi will be always positive. But if phi is negative, then sin phi will be also negative. And then lastly, active power. Reactive power. And apparent power. Right? So the numerical will be given to you that Z equal to this is connected across 440 volt. So Z means this is given across 440 volt means VL given voltage in the numerical is always line voltage is given. Calculate anything can be asked. So first ZPH, IPH, then IL, phi, cos phi, sin phi, and right? So we will solve the numerical for delta as well as star. Z means it is ZPH. Given Z is always ZPH. 4 plus J3 is connected across 440 volt. Calculate all the powers. This is the question, suppose. Z can also be written as this is rectangular form of Z and this is polar form of Z. R plus J XL minus XC or R square plus XL minus XC square. Plus J means XL and minus J means XC. So it is plus J, that means this is XL. Right? So first step VPH. Sorry. We will calculate all the powers for star and delta. So this voltage is line voltage. First you have to calculate VPH. VPH is equal to VL upon root 3. Suppose this is 4. And VPH is equal to VL. For star, VPH is VL by root 3. For delta, VPH is equal to VL. So 400 by root 3 is 231 volts. And here VPH is equal to VL, means 400. Right? So now first answer. First step. Now start step wise. ZPH under root of R square plus XL square plus J. XC is not given. ZPH under root of R square plus XL square. So is equal to under root of R is 4, XL is 3. R is 4 plus J XL. XL is 3. 4 square plus 3 square is equal to under root of 4 square plus 3 square. This is 5 ohms. This is 5 ohms. So first answer is calculated. Second answer. IPH is equal to VPH upon ZPH. VPH 231 upon 5, 400 upon 5. VPH here is 4. That is IPH. Then 3 then 3 for star IPH is equal to IL, and for delta IPH is equal to IL is equal to 3 IPH. IL is equal to IPH for star and IL is equal to 3 IPH. So 46.5 ampere. And here IL is equal to 3 IPH. So 3 into 50. Right? Then fourth one, phi tan inverse of XL minus XC upon R. This is plus J means XL. Tan inverse of XL upon R. Capacitor is not given. Tan inverse of XL upon R. Tan inverse of 3 by 4. Tan inverse of 3 by 4. Now, suppose the numerical is like this. R is equal to 10 ohms in series with inductor of 50 millihenry are connected across 230 volt 50 hertz supply. Calculate again on this if this is the question. Now R is given in ohms and L in millihenry, so you have to calculate XL equal to 2 pi. R is equal to 10 ohms, XL equal to 2 pi, FL 2 pi, F is 50 hertz and L is 50 millihenry, means 50 into 10 raised to minus 3. This is 2 pi into 2.5, 15.7 volts. The given voltage is line voltage. VL is equal to 230 volt. Now for star, VPH is equal to VL by root 3, and for delta, VPH is equal to VL. Then ZPH under root of R square plus XL square, and here also ZPH is equal to under root of R square plus XL square. And again same as we have solved above. So what care you have to take, if Z is given in ohms, 10 plus J 15.7, then it is both values are in ohms, XL is given. 10 minus J 15.7 minus J 15.7, then it will be X minus J. If C is given 500 microfarad, then you have to calculate Xc is equal to 1 upon 2 pi Fc. Convert it in ohms and then use. This all we have studied in first year. Right? So now I will give you 4 numericals solved. I will mention the formula also, how to solve the process. I will solve it on a page and I will upload the photographs on your WhatsApp number. You go through it, but while observing the video, you are having notes I am sending you on WhatsApp, but then also I request you to solve this numerical in your copy, in your notebook. You consider that you are sitting in a class, I am teaching you on blackboard and you are noting down everything on the copy, notebook. Similarly, observe the video which is uploaded on YouTube. Go through the notes uploaded on your WhatsApp number, but at the same time, as I am giving you the methodology, as I have solved it on a page which is sent to you on WhatsApp number, you also try to solve that numerical. Until and unless you try it yourself, until and unless you use the calculator only by observing is not sufficient. You will have to solve, you will have to use the calculator, you will have to calculate the answers. I am giving you the ready-made solution, but then again it is requested to solve at your own, which will be sufficient for you from exam point of view. Okay, so I will upload 4 numericals, star and delta. Now one important thing I am telling you, keep in mind, we are calculating power, active power, reactive power, apparent power. In each numerical, we will calculate these three powers for star as well as delta. One numerical for star as well as delta. Second numerical for star as well as delta. And in both cases, we will calculate these powers. So what you have to note down? Powers in star and powers in delta. What is comparison? What is comparison? Power in delta is 3 times power in star. Power in delta is 3 times power in star. You check it. And if it is okay, then your numerical is okay. Suppose power in delta is 1 watt. Active power in delta is 1 watt. Then active power in star is 1 watt. If active power in star is 1 watt, then the active power in delta will be 3 watt. If reactive power in star is 2 watt, then reactive power in delta 2 into 3, 6 watt, 3 times. If apparent power in star is 3 watts, then apparent power in delta will be 9 watts. All the powers in delta are 3 times power in star. That is a check whether we have solved the numerical properly or not. In exam, you will have to solve the numerical either for star or for delta. But here, I will give you one numerical, I will take one numerical, I will solve it for star as well as delta. Second numerical for star as well as delta. So we will solve 4 numericals, but in exam you will be asked to solve either in star or in delta for 6 marks. Is that clear? So I will upload the video on YouTube. I will send you the note on your WhatsApp number. But again, while observing the video, while going through the notes, you yourself also try to solve the numerical. You yourself also try to solve the numerical using calculator. Get sufficient practice on calculator. Check the answers. My answers and your answers are matching or not. Power in delta is 3 times power in star or not. Then your practice is okay. Perfect. Right? See you.